welcome to my first video where I'll be teaching programming concepts. If you don't recognize this website I am on, you probably did not see the first video in this series where I explained what it was, so you should go and have a look at that before you try to watch this one. In this video, I am going to be running a program I created and demonstrating and explaining what it can do, and then I will spend the rest of the video teaching you all the concepts you need in order to fully understand the way the program works, and then I will encourage you to go and create a similar one. The program I'll be running today simulates an extremely simple and limited conversation with whoever is running it via text, meaning the computer talks to the user by displaying, or the user is whoever's running it. So the computer talks to the user by displaying text, and the user talks back by typing. There's no voice recognition. Programs which simulate conversations like this are called chatbots, and we may be looking at a few of these in future videos. Speaking of future videos, I will now talk a bit about what I'm going to be doing in this series as a whole. We're going to start with just some basic programming concepts for an undetermined amount of videos, but later on, which might even mean in the next video, I'll be teaching some graphics and game mechanics related code, and I'll be showing you everything you need to create games in Java. Back to today, before I run my program, I would like to inform you that the window containing this text I am reading from is called the programming editor, and the black, or this window here is called the programming editor, and the black window over there to the right is called the console, this here. The console is the text editor where the chatbot will display its messages, and the place where whoever's running the program, who is referred to by programmers as the user, will be typing their responses. As you may have guessed, the code which actually tells the computer what to do when the program is run is located in this program editor here, which, yeah, like I said, is this window here. And this text you see, however, is not the code which makes the program work. It is just the script for this video. The code which makes this program work and actually do the things it does is located further down the page. My script here is something called a comment, which means text in a program editor which the computer has been instructed to ignore, and so does not affect the way the program runs. This function is useful for allowing the programmer, meaning whoever is writing the code, to leave notes in their code describing the way it works. I'm using the comments to do both that and to keep my script where I can see it, and you can review it later. In Java, the programming language I'm using here, the way to write a comment is to type a slash, then an asterisk, then the actual material you want to have in your comment, followed by an asterisk, then another slash. Oh yeah, right. So I'm just going to show you the ones at the beginning of this comment here. As you can see, there's an asterisk and a slash, then an asterisk at the beginning, and at the end of this huge comment. Oh, it's actually really long. There, that's the end of it. That's another asterisk followed by a slash. That tells the computer that that comment ends here. Just let me scroll back up to where I was. Okay, now without further ado, I will run the program. So the bot says these things here, this, and I'm just going to respond. Okay, that was a pretty short conversation. Pretty uneventful. Okay, I don't know, let's say something other than well, let's say poorly. I was having so much fun till you said that. Why you gotta ruin my day like that, you jerk? Rude bot. Okay, well, let's run it again. See if it'll say anything else. So it says these things again, because that's always how it starts, and then I'll say something like, well, or I'm alright. So it says I'm well too. What is your favorite pet? So I'll just say something like dogs. Huh, I've never even heard of those. You're trash. Bye. That's interesting. The bot has never heard of dogs, and it's being rude. Okay. Well, anyway, jokes aside, the way it works is if you say poorly at the beginning, it just says this, which you've seen, and then if you say anything but poorly at the beginning, it asks about your favorite pet, and if you get to the point where it asks about your favorite pet, and then you reply with iguanas, it says agreed, they're the best, and if you reply with anything that is not just iguanas, then it says I've never even heard of those, you're trash. That's what I programmed it to do. I'm not actually surprised that it said that. I just thought it'd be funny if I got it to say those things. Then no matter what it says earlier on, it always says bye at the end. Look, I'm just going to run you through the cases, all the different cases again. I click run. Okay. Okay, there's the first case, and it says bye at the end. Run it again. By at the end, but it's clearly a different case. So I run it again. It says this, and I could say something like, quite well. I'm well too. What is your favorite pet? Dogs. And see, it says by at the end. It always says that at the end. So the first instructions that I wrote to make it behave the way it does in this manner can be translated to English as follows. Say, nice to meet you, how are you doing? After saying, hello there, I'm a super basic chatbot. Then wait for the user to respond. Then check if the user said poorly. But after this part of the instructions, however, it becomes more difficult to translate to human language because I would now have to write two sets of instructions for the computer to follow, one for the case where the user says poorly and another for the case where the user does not say poorly. I could just translate both sets of instructions from here and put them in this comment separately, but it would be more useful for me to explain something called a decision tree first, as a decision tree is something that will allow me to put all this code into one diagram. A decision tree is a diagram of the choices a computer is making when a program is run, where every time there are multiple things it could do, we write on the decision tree a condition it will check, or more like a statement it will check. So if the last thing the user said is poorly, so that could either be true or false, then we draw a line from the condition it will check to the next thing it will do if the condition proves true, and another line from the condition it will check to the next thing it will do if the condition proves false. In my decision tree that I'm about to show you, assume that all lines beginning after conditions will be labeled with the case which will result in that arrow being followed, like this. So here's the condition up here, the line where I tell it to check a condition, and then you have the word true and an arrow pointing to instructions to be followed if the condition proves true, and then we have the word false and an arrow pointing to instructions to be followed if the condition proves false. So here's where the diagram for this program actually begins. So the bot says, nice to meet you, how are you doing? Then waits for the user to respond, then checks if the user said poorly. If the user said poorly, this condition here is true. It will say, I was having so much fun until you said that. Why you gotta ruin my day like that, you jerk? Then, if we follow this arrow, it runs down here, here, there, and it says bye. And as you can see, all the possibilities join up to bye at the end. There's 3 possibilities, grand total. So if the user says poorly, or if the user does not say poorly, then it says, I'm well too, what is your favorite pet? It's basically assuming the user said, I'm well, which they wouldn't necessarily have said. But for now, we're just keeping it simple. I might show you how to check all the different things the user could have said in a future video. But anyway, then after saying this, it waits for the user to type, basically, and then it checks if the last thing the user said is iguanas, and if the last thing the user said is iguanas, we follow this arrow. The computer says agreed, they're the best. Then it says bye, and if the last thing the user said is not iguanas, then it just says, ha, I've never even heard of those, you're trash. And then it goes, follows this arrow and says bye, no matter what. So as you can see, in this tree diagram, there's these decisions, and the list of cases of things it could be doing like branches out over time, but then it all joins back together at the end. Most programs work this way. Like there's more and more branches as you go further down, but then all of them, or at least a lot of them, will join up at the end. So this chart covers the decision-making process that this program goes through in order to work the way it does. Before I show you how the code works, let me tell you a few things about the code you're about to see. First, unless I explicitly tell you otherwise, anything that you see is not a comment, or that is not a comment. It's just setup code, which allows us to add more code later on. I will paste the setup code into the description below the video so you do not have to copy it out by hand. Secondly, when you run a program, the computer will follow all the commands where following the commands is referred to by programmers as executing the commands. And it will execute these commands that you put into the programming editor in an order starting from the commands at the top of the page and finishing with the ones at the bottom of the page. And thirdly, when you see commands that I have written, you will need to write those commands in the exact same way I do. If you write even a single command not in the exact format the computer expects, it will do something called crashing instead of anything you programmed it to do. This does not mean you have to use the same commands I do in the same order I do. If you had to do that, you would only be writing programs I've already written. The only way you determine what a program's going to do is by using different commands in different orders. It just means that you can't write individual commands incorrectly. You have to write them the way the computer expects them, the way they're supposed to be written in the given language. So when I refer to format of commands that a computer expects, I'm referring to things like periods between words, which are present in some commands, semicolons, which are present at the ends of almost all commands, and capitalizing correct characters, and using the correct type of brackets. There are three types of brackets, the first of which I will call round brackets, or more often just refer to them as brackets, and they look like this. The next of which I will call curly or curvy brackets, and they look like this. The last of which I will call square brackets, and they look like this. So, I now recommend that you empty your REPL of any auto-generated starter code, then copy the starter code from the description below the video, and make sure that nothing happens when you run it, other than the auto-generated junk at the top of the page, of course, appearing. If any error messages are displayed when the program is run, you already have some kind of incorrectly command, known by programmers as a syntax error, and should not continue coding more stuff until the problem has been resolved. The way to resolve the problem would be to simply empty your REPL so there's nothing there, and then copy and paste the setup code from the description in the video into it again. So now I'll begin showing you the code which makes this chatbot work. The 6 lines after this comment are just setup code, like I suggested would happen earlier. When you begin actually writing code into your REPL, you do not need to write all your code. No, sorry, you will need to write all your code after these lines. Do not write any code before them, and do not write any code between them. For instance, here, don't do that. Also, do not write any code after the close bracket, which I am now about to show you. So hopping down to it, close curly bracket 1. There we go. Nope, not that one. This one here. Do not write any code after this one. It's going to be the second last one that appears on the page that you can't write any code after. So putting code here is fine. But don't put it here. Okay. And even if the brackets move, just as long as you put code here, you can put code here, you can put code here. It doesn't matter what line number it is, just as long as it is a line number higher than the line number of the second last close curly bracket on the page. So I'm just going to erase these spaces, hop back up to where we were to begin with. Okay, so the next 6 lines of commented out code, this stuff here, that you can tell, just note that you can tell the difference between comments and code the computer actually reads, because comments will be grayed out like this or like this, and other stuff will be displayed in colors such as black, blue, or red, like this. And these lines here are called print statements, and they make the computer display whatever you type in between the brackets to the console. It makes it display it here, and then it moves the console cursor, meaning this white rectangle, the position of which is where any print statements that are executed print, meaning whatever the computer is displaying as a result of the program being executed is displayed starting from this white rectangle, so that this white rectangle moves to the next line after one of these print statements is executed. So the reason that it's relevant that this moves to the next line is that if we put things in 2 separate print statements versus in the same one, if we put them in 2 separate print statements, they will print to 2 different lines. If we put them in the same print statement, they will print to the same line. The way print statements are written is system.out.println, open bracket, the stuff you want printed, close bracket, semicolon. Note that the above, this here, is actual code. However, the computer will treat it like a comment because it is between the last slash asterisk and the next slash asterisk, this one here and this one, okay, or no, the next asterisk slash. which leads me to an important point. Not only can comments be used to write explanations in human language of what code is doing, but they can also be used to temporarily disable code that you do not want to delete. In fact, I actually have a few examples of small programs I want to show you further down the page, and one up here as well, that are currently commented out, but that will run properly the moment I uncomment them. Now I'm just going to go comment out the code that makes this bot work the way it does, and hop back up to this line by searching for this word using Control F. So I'm just going to search for the bot code. Using the word trash, it's only going to appear once. Oh, nope, it appears 3 times in this page for some reason. That says something about me as a person. Okay, comment out the bot code. Hop back up to the beginning using line 1. Okay, now we're back. So now I will run this code here. It will actually work. I press run. And as you can see, it prints 4 blank lines after the junk paragraph. I wanted these blank lines here so that nothing's getting crammed up against this, and you're not confusing the stuff that's printing as a result of my program with the junk. And it prints this on 1 line because that's what's in the first print statement, and it prints this here on the next line, and then it stops because, like, this is just the beginning of the chatbot, but it's not going to do the rest because the code to make it do the other things is not there anymore. So I'm just going to re-comment this. Also note that in my above commented out example of a print statement, this one here, I did not include the double quotes that I included in the actual print statements. These are the ones here that I'm referring to, the actual ones. See how there's double quotes after the brackets and before the close bracket? Hang on. Yeah, the reason I did this, this was intentional, and I did it because all the double quotes do is tell the computer to treat whatever is between them as something called a string, which means a series of characters which the computer can either print or use in a comparison in a condition, as opposed to actual code to be interpreted. Sometimes in a print statement, we might, instead of putting a string into the statement ourselves, put in some code which will replace itself with one string for us. That may sound confusing, but all you need to take away from it for now is that the double quotes are only for if you want the computer to treat the content between them not as code, but as the characters that make up that content. So when it reads the words, hello there, I am a super basic, or the bot, hello there, I'm a super basic chatbot, it's not trying to figure out what this code means, what command this is. It just says, oh, print this stuff, print these characters. So I now suggest that you go and write your own print statement in your REPL before moving on, using the double quotes and putting the strings in yourself so that the computer treats whatever you put into the statement as a string. I haven't shown you any other way to actually have it print anything. So yeah, whatever you're going to have it print, put between double quotes. I also suggest that you follow my example of having a few blank print statements at the beginning of your program so that the material you are printing does not print right up close to the junk paragraph at the beginning of the console. Now, I'm going to move on. So anyway, you can just pause the video now if you're going to do that. But now I'm going to move on. So the next tool I need to show you that I use to make this chatbot is called a conditional statement. And it gets the program to check some condition you include in the statement. Typo. And then if that condition proves true, the computer follows some set of commands you include in the statement and then proceeds to follow the commands after the conditional statement. If the condition proves false, it skips the commands included in the conditional statement and then proceeds to execute the commands after the statement. So I will now talk you through an example. The way that conditional statement, where is it? It's pretty far. Oh yeah, here. This conditional statement here will work if I execute it is it will cause the computer to first determine if the string I put before the word dot equals, so this string here is the same as the one I put between the brackets after the dot equals, so this one here. If they do prove to be the same, which in this case they will, because it THIS all lowercase, THIS all lowercase. If they do prove to be the same, the condition will evaluate to true, and the computer will print the if code. That's not a term, that's the string I've put here. That's the contents of the string it's printing. Then it will move on to the code after the closed curly bracket, and as a result will print the after code, which is again not a programming term. It's just the material I have in my print statement. If I were to change one of the two strings so that they were not equal, however, then the condition would evaluate to false. The print statement between the curly brackets after the word if. So we have the word if, and we have all the stuff on its line, and then we have open curly bracket, a print statement, and then a closed curly bracket. And there could be multiple print statements. I just only have one here. So all of these, everything between the brackets would not execute. It would be skipped, and then the computer would continue executing commands here. So this would still be printed. So also note that I have two round brackets here at the end. That's because this one here is closing off this one after the dot equals, and this one is closing off this one. This one. Whenever you write a conditional statement, you need to put an open round bracket and a closed round bracket, and the condition goes between them. And whenever you are comparing two strings, you need to put dot equals and then brackets after them. After it, open round bracket, close round bracket, and between those you put the second string that you're comparing to. Note that I put quotes around the words that we're checking to see if they're the same because, like I said, I want the computer to recognize that they're to be interpreted as strings, not executable commands. Now try to guess what the following code, this here, will do when I uncomment it. Actually, first I'm just going to demonstrate what this does. Oops. Okay, so I uncomment this code here. Well, oh no, hang on, I've already told you. Oh, you're right, sorry, you're not supposed to be guessing what this does, you're just supposed to observe. So I press run, and as you can see, it prints the if code, then it prints the after code. If I just change this to be something else, run it again, this will not prove true, and it will just print the after code. Okay, I think you get it. Now, try to guess what this is going to do when I uncomment it and run it. Okay, I'm going to do that. Uncomment, run. So it prints the blank lines. Oh yeah, and it crashes because I omitted the semicolon at the end of this print statement. Also, you'll see that even though the error is at the end of the code, the entire program fails to start. Java confirms that the code will work before actually running the program. In some languages, it might have executed these and then checked this and then executed this if this statement was true and then gotten to here and then crashed because there was a problem, but Java will just crash right away if there are any problems. So watch out for that. If you make even a single syntax error, the program will not run. It won't do anything. Alright, now try to guess what the following will do, this here. Okay, so I uncomment it, I press run, and it just prints out 3. It doesn't print out 1, 2, 3. It would if I remove the word different and the space and then ran it, because this would prove true. So it would do this and then that. But because this proves false, it skips everything between the brackets. So it also doesn't do 2, 3. It doesn't just skip the one command after the if statement. It skips all of the ones between the brackets, which are commonly referred to as the body of the if statement. Just going to recomment it and move on. All right. So now I encourage you to write your own conditional statement after noting that you should never put a semicolon right after the round bracket part of a conditional statement. Doing this will not cause a crash, but it will instead cause the conditional statement not to work properly, a problem the source of which will be hard to identify as the program is not crashing. I have once actually spent 4 hours trying to find my misplaced conditional statement in a program for a robot I wrote, when the reason the program wasn't working was because of an added semicolon like I just described. Everything else was perfect, but I'm still never getting those 4 hours back. Yeah. So the next thing you need in order to create a chatbot that works is, oh yeah, sorry, I just remembered what I was about to say. If you have problems with code, try deleting a bunch of it and then just running progressively less and less until the program does not crash, and then start putting the other code back one line at a time and running it every time you put a new line. That way, you can, there will only ever be a few lines that are suspect problems, sources of a problem if the program does crash. For instance, if you write 5 lines of code, then you test the program and it works, and then you write 5 more lines and you test the program and it works, and then you write 5 more, you test it and it breaks, like it crashes, you know the problem's in the last 5 lines and it's easier to find. Now, the next thing you will need in order to create a chatbot that works is the command I showed in my flowchart that said get user input. I'm just going to go back up to it. See here, wait for the user to respond. Okay, now I'm just going to go back to where I was. There I am. So this is not how it is actually written in Java. It's just an English translation. The way to do this, not with a new command, or is not with a new command that takes up an entire line, but with something I call a subcommand. Note that subcommand is not a real term, but it serves my purposes very nicely. I'll get to the actual name for subcommands and even details about how to write your own subcommands in a future video. But back to today, however, the subcommand we need to get user input is sc.nextLine, capital L, open bracket, close bracket. Like capital L in line, not next line, then a capital L, like in println. No. This is the way it's written. So this subcommand here tells the computer to pause the command following process, allow the user to type until the user presses enter. Then when the user does press enter, the subcommand replaces itself with whatever the user typed into the console, and then tells the computer to continue executing commands in sequential order. This is just an instruction I wrote for myself to widen the program editor so I could read everything. I'm going to do that now. Yep, still needs to be wider. Oh, hang on. Get rid of this junk. So, if you're confused by that explanation I just gave you, and where I said it replaces itself with, don't fret, I will now explain, typo, explain, yep, with an example. Consider the following. So this is like a graph, or not a graph, but a chart I've set up here. This number here represents a point in time. This here is the code the machine is basically reading, and this here is just what the console will look like, where this line here, I don't actually know what you call this, embarrassingly enough, represents the console cursor, the white rectangle. So at the first point in time, the computer is reading this line here, and the console looks like this. At the next point in time, the computer is reading this line here. This is not part of the line. This is just an indicator I put for myself that tells me which line it's reading. And the console will look like this. It will have printed this. The rectangle will be here. And note that this command here is in this line, this command that gets the computer to replace or to get user input. So at the next point in time, it will still be reading this line, and it will, and the user has typed something in, okay? So just the name Tom in this case, oops. And the user has not yet pressed enter in this at this point in time. And then in the next point in time, the user has pressed enter. As you can see, the console cursor has moved on to the next line, and the command sc.nextLine has been replaced in the code by whatever the user typed in. It doesn't replace itself permanently. Like if you run the program again, it will still behave as if this were here. But for the current run, for the current line, while the computer is looking at this line, it will be replaced. So now the computer just behaves as if the string Tom were there to begin with. And then it will print out at the next stage. It finishes with this line and prints out this here. So it prints out the word Tom, or the name Tom, because that's not a word, it's a name. And then it prints out, "It is nice to meet you," as you can see here. So that's what I mean by it replaces itself. That's the way this sc.nextLine command behaves. So the purpose of this chart, again, is just to demonstrate that between lines 3 and 4, the user presses enter, and the computer removes the subcommand sc.nextLine from the machine code and replaces it with whatever the user typed. So I'm now going to give you an example of a chatbot that does this. So I uncomment it, and I click run. It prints its blank lines. It says, "Hello there, I'm a super basic chatbot. It's nice to meet you. How are you doing?" And if I just say, "Hey chatbot, you suck!" exclamation point, because I'm just mean. I press enter, then it says, "Ouch, that was unnecessary." And if I run it again, and I say anything other than that, it just doesn't say anything. So if I say like good, it just sits there in silence, because I didn't need to make a complex decision tree for this program, because I was just trying to demonstrate this sc.nextLine thing. So in this conditional statement, I've put if sc.nextLine dot equals "Hey chatbot, you suck," print this out. And as you can see, I have not, actually I'll just get to that in a moment. So yeah, I've put this command or this subcommand into the conditional statement. So the computer will actually be on this line and just sitting here waiting for you to put something in for it to check before it compares this to that. Because this here isn't a string, it's a subcommand, so it knows not to do this check until this has replaced itself. So moving on. Comment this out. Now try to tell me what will happen when I run the following code. System.out.println sc.nextLine, system.out.println sc.nextLine. Note there's double quotes here, and there are no double quotes here. Okay, just gonna uncomment this, and then run the code. Okay, so it's finished loading. So it's waiting for me to type. That's what's happening right now. It hasn't printed anything telling me that, but it is, I assure you. So I'll say something like hello, then I press enter, and it prints out the word hello, and then it prints out sc.nextLine. It doesn't print hello again, and it doesn't wait for me to type again. Because this here, by putting the double quotes, I told it to interpret this as a string instead of as code to be executed. And that's what I meant earlier when I was talking about putting these versus not putting them. There are cases where you won't be putting quotes in print statements. This is one. So now I'm just going to comment all this out. Now, I encourage you to write some code which uses the sc.nextLine subcommand of your own. Now I'll just tell you a few additional things about conditional statements and print statements, and you will have everything you need in order to write a chatbot like the one I showed you today. The next thing I will show you is a special type of print statement where the ln at the end of the word println is omitted, like so, system.out.print, open bracket, close bracket, semicolon. The way this type of print statement differs from the first kind in its functionality is that it does not move the console cursor to the next line. Try to guess, based on those implications I just told you up here, what both of the following will do, both of two following pieces of code I'm about to show you. So try to guess what this one will do and what this one will do. Alright, I'm going to uncomment this one, run it, show you. Uncomment, run. It prints, "Hi there, friend," all on one line. Okay. I'm just going to re-comment it so it doesn't confuse you with anything else. I'm going to press run. And it prints, "Hi there, friend," on two different lines, because this one is just a print statement, and this is a println statement at the beginning. So this one goes print hi there, print friend, move on to the next line. This one goes print hi there, move on to the next line, print friend. So commenting this out, moving on. These print statements with no ln can be useful for having text dialog labels telling us who is speaking. For example, I'm just going to run this bot here. Run. So this one says the bot, hello there, where is my body? Now this I could have achieved without using just a regular print statement. I could have done this with a print ln statement. However, this one here I could not have done because there's no way to have it print something out and then read user input with one command. At least not that I know of anyway. So I put a print statement and then I put sc.nextLn in the next command. So it's waiting for me to type. So I'll say just some random thing. I don't know. And it just says bye because, again, I only programmed it to do one thing. Otherwise, it just does nothing. I could just say, you don't have one. You are just a program. Oh, I omitted the period. As you can see, I'm just reading it from here. You don't, have one. You are just a program, period. Enter. Oh, that's unfortunate. Bye. And again, I forgot to label this, which is kind of funny, but whatever. So, as I said, system.out.print is useful for labeling something when you don't know what you're going to be printing yet. If you know what you're going to be printing all at once, it's easy because you can just put it all in one print statement. But if you don't know what you'll be printing later on, or if you don't know what's going to be on that line, for instance, if the user is going to be typing it, then you want to use just a regular print statement like this. So now I'm going to comment this code out. So as you can see, this bot we programmed here displays things in the console in a manner where we can tell who is supposed to be talking. The next thing I should show you is an extension of conditional statements and is called an else statement. Hello again, I'm back. Just had to cut out for a second. So anyway, I'm talking about else statements, and an else statement is always typed after an if statement, like so. If, then the condition, then the brackets and the code between them, then the word else, and then curly brackets, like for the if statement. These are curly brackets, not round brackets, and then some other code that you put between them, which you would refer to this code, all of it, even if it's multiple lines, as the else block, and you refer to this code as the if block. Remember that the if block executes only if the condition is true. Well, the else block executes only if the condition is false. Try to guess everything the following will do when I input hi there, and what it will do when I input anything else. So here's the following I'm referring to. So here it is. Here's all this code. Try to read this and interpret, and guess what it's going to do. Okay, now I'm going to run it. Run. Okay, so the bot says, hello there, user, where's my body? And I could say, oh, hang on. Actually, that's just a relic from the earlier stuff we were doing. Yeah, I forgot to uncomment this. That's not part of the code I was trying to run right now. Sorry. Totally throwing you off there. Trying to psych you out, that you question your decisions. Okay, so I run the code. So it just says, looks over at you, like a narrator saying that almost. And it prints out the user, and I can say something. So I'll say hi, and it just says hello, then bye. And if I run it again, it looks over at me, and then I'll say something other than hi. So, what's your name? Oh, hang on. your name, question mark, enter. It just says, I don't know what that means, bye. So the reason for that is that this code here was in the else block, so it ran. I don't think I need to explain how it works that much. Basically what it does is it just does all this stuff, which you can understand, goes to the conditional statement, which contains an sc.nextLine, checks if what the user is saying is equal to hi. Then if it is, the bot just says hello, and otherwise, that's what this means. It says, I don't know what that means. So it will always do one of these, but never both, and then it will also always say bye afterwards. So now suppose, hang on, let me comment this out. I'm obviously going to have another example later on. So now suppose we wanted to change the above chatbot so it would not just say I don't understand. Don't know why there's a capital S in the middle of a word. But so that it would say I don't understand. What does then insert the last thing the user said here mean? There are two steps the computer must take to doing this. The first of which is to actually remember something the user said previously for more than one line. The second is to auto-generate the thing it remembers the user saying into a print statement. The first command we will need to use to do this is one which tells the computer to reserve a space in its memory for a string, and tells the computer that, or it tells the computer what name we will give that space. Basically, we are naming a subcommand, which when we write that subcommand later, will get the computer to auto-generate the contents of the memory space into the code where the subcommand is written. The same way the sc.nextLine command works, subcommand works. Here is an example of such a command. String the name. That's the first command. So the word string tells the computer that we are reserving a space in its memory for a string, and the word the name is just the name I picked for the subcommand that would auto-generate the contents of the memory space into the code in the future. The memory space is referred to by programmers as a variable. Creating one is called declaring a variable. Unlike the term subcommand, which I made up, these terms are actually used by all programmers. The next command I will need to type in order to get the bot to behave in the way I described. Tells the computer to actually fill the space we reserved in its memory with whatever the user types next. It is written like so. The name equals sc.nextLine, open bracket, close bracket, semicolon. The word, the name. Oh yeah, so the word, the name, tells the computer which memory space we are talking about. The single equal sign tells it that we are filling the space with whatever appears to the, not the left of the equal sign, the right of the equal sign. The right of the equal sign, and you already know what the sc.nextLine, open bracket, close bracket, subcommand does. Note that, like with print statements, these two commands must end with semicolons. Note that you should never declare a variable inside a conditional statement, like the if or the else block, unless I explicitly tell you otherwise, because variables written inside conditional blocks actually cease to exist after the conditional block in which they are written ends. So now I encourage you to try to write your own chatbot, which works like the one I wrote above, except if you don't tell it what it is expecting, it says something like, I don't know what, then puts whatever you said here means. Alright, now I'll show you the one that I made. So, uncomment it. So the first line of code I have is this one here, the one that tells it to reserve a space in its memory and names the space or the subcommand that gets us the contents of the space, last comment. Then I have my blank print statements. Then I have the bot say it looks over at you. Then the computer prints the user, so like sets basically indicating that you're supposed to talk now. Then we store whatever the user types next into last comment. Then instead of using sc.nextLine again, we use last comment here, because if we use sc.nextLine twice, it will just have you type twice. So we say if last comment dot equals hi, the bot prints hello, else the bot prints, notice that I don't have an ln here, I don't know what, and then the the value of last comment, which is again what the user said the first time. If I put sc.nextLine here, it would just have me type a third thing. So it wouldn't say, it doesn't know what the first thing I said means. It would say, it doesn't know what some other thing that it just gave me a chance to say means. Then it prints means. Notice that it moves on to the next line here, because otherwise it would then print by on the same line. So if you haven't managed to do so already, I encourage you to now go ahead and create a chatbot which remembers things the user said, like this, with this last comment equals sc.nextLine string last comment line. Remember, this name can be anything. It could be the name, last comment, random word, whatever. Just refer to it the same way every time you refer to it, and refer to it the same way as what you say you're going to refer to it as up here. So if whatever you try to write even now doesn't work for you, you should have a look at this example, because I suspect you made this mistake. I go run, and we get a crash. So look how this works. We have print statements, and then it just says, it's supposed to say the user, indicating to us that we should be typing, and then we say, and then it just tests if what we type is high. Oops. And then it assigns the word stuff to a string we declare here, and then it just prints out the value of the string we declare here, which in this case would just be stuff. However, like I said, you're never supposed to declare a variable inside a conditional statement, because if you do, it will be forgotten, it will cease to exist, it will be erased after this. So we could actually use it for things in here. Like if we were to move this line in here, it would work, but because it's here, it will not work. And the computer can tell that this will happen immediately, so it just crashes. It doesn't even try to run this. I'm just going to recomment it now, because if I leave it uncommented, it will just cause everything else we try to run for the rest of the video to crash. So the only other things I did in my chatbot that I showed you at the beginning that I haven't shown you yet how to do is put conditional statements inside one another, commonly referred to as nesting them inside one another by programmers. Again, actual term, not like the word subcommand, more like variable and declaring a variable. So, and then I've also changed the contents of a variable after I have already set them to something. All you need to know about nesting conditional statements is that the conditions of the inner statements are only ever checked if the block they are in is run. And all you need to know about changing the contents of a variable is that you just repeat the variable name equals stuff we want to fill it with, semicolon, command. Now try to guess what the following would do. Oh, I'll just uncomment it before I show it to you. I won't run it, but like I will run it, but not before I show it to you. Okay, so now I go up. So try to guess what it will do, and more specifically, try to guess what it will do in the event that I say hi, and the event that I don't say hi, and the event that I say well, and the event that I don't say well. Okay, now I'm going to run it. Oh, why is there a problem? Okay, so these are error messages that I was referring to earlier. I am just going to try to find the source of the problem really quickly. If I can't, I will just cut this part out of the video and finish, or just continue recording afterwards. Where is the source of the problem? Oh, I found it. I omitted the word string here. So I put the word string there because when I declare it, when I declare it the first time, it needs to. Actually, that's not something I've shown you yet, so I'm just gonna get rid of that. And basically, what I did is I just forgot the line where I declare the variable. So I'm just gonna quickly add it. I'm gonna go right at the beginning, string last comment. Okay, now I run the code. It should work. Run. There we go. problem solved. So the bot looks over at you. I say hi. It says hi. How are you? If I say well, that's nice. Bye. I didn't bother to put captions. Well, actually did at the beginning, but then I got lazy later on apparently because they aren't appearing here. Or dialogue labels, not captions. So now I run again. I say hi. I say anything but well. Nah. I'm sorry to hear that. Bye. Run it again. I don't say hi. I say, what's your name? Question mark, enter. And the bot says, I don't know what what's your name means. Bye. There's a question mark in here, which is kind of confusing. It's just there because it's in the material I typed. Yeah. Okay, so that's what it does in all 4 cases. I think I showed you all 4. So now I'm just going to comment this out. Oops. Yeah. Comment this bot here out. And as you can see, it only asks the user how they're doing if the user says hi at the start. Otherwise, it just says it doesn't understand and then says bye afterwards. It doesn't bother checking. It doesn't ask them how they're doing if they say hi at the beginning. So the tree diagram for this chatbot would look like this. So first there's the opening statements, but I didn't even bother to put them because they're not really relevant to the decision tree. So then we check if the user said hi, and if they did, we go this way. So then we say, how's it going? And then we check if the user said well, and if the user did say well, we say that's nice, and then we say it was nice meeting you, and then we say bye. If the user does not say well, backtracking to this last condition, if the user does not say well, we say that's too bad. Go back down to over here, say it was nice meeting you, and then say bye. Hang on, is it actually saying it was nice meeting you, or did I just say I told it to say that and then didn't make it say that? No, I didn't make it say that. Sorry, hang on. I'm just going to edit this code so that it actually does follow the control structure. Okay, there, it's there. Actually, I should probably run it again. Yeah, I'm going to do that. No, I'm not going to bother. What it does, basically, is just, it's only going to say, it was nice meeting you if it gets to the point where it asks how you're doing, but it's going to say that no matter how you say you're doing. So it's only going to say, yeah, you guys clearly get it. So, anyway, then it would say bye. And if the user does not say hi, it just says, I don't understand, and then it says bye. So again, we have this tree that branches out more and more as it goes, so it branches out 2 ways, and then it branches out again on one side so that there's 3 ways, but then the 2 come back together to say it was nice meeting you, and then the it was nice meeting you branch, which is now these 2, comes back together with this one to say bye at the end. So when writing more complex programs in the future, you may want to map out their decision-making processes with a diagram instead of just trying to code it right away, because it's just a little bit easier to think about when you visualize it with a tree diagram. If you do choose to do this, remember that for the structure where letters with question marks mean conditions and letters with no question marks mean commands. No question marks mean commands. I've just, for my example, we have command question mark true false goes to B, goes to C based on if it's true or false, and then both of those go back to D. This structure here is coded as this, and this model here, this can actually be used for any program which doesn't do things repeatedly, which is not something we're going to go over today. We will definitely have to do it in future because that's a huge part of programming, but for today we won't be looking at doing things repeatedly. So even if there are nested conditions, you can still just substitute an entire block like the above one in for one of the letters B or C. So think about how this model could be used to represent the previous bot. What you have to realize is that this model here, it doesn't represent the entire bot, but it does represent just this bit here. Did the user say, well, check that, do this, do this, do that? So from here to here is in this format, but then if we just like remember this as one statement, like B, then this here actually does represent the structure of the whole thing, because the A condition we're checking is, did the user say hi? And if they didn't, then we just go to C, which is saying I don't understand, and then we go down to the end, which is saying bye, which is D. And then if they did say hi, we go to B, which within B is another substructure like this, which is, did the user say well, say these things, say one of these things based on if they said well, then say this, then go on to the next thing, which gets us to D. So all structures are actually just basically just this structure here nested inside of each other again and again, or at least they can be written that way. So now you have actually seen all the tools I used to create the chatbot at the beginning. Now go ahead and try to create the one I showed you at the beginning. Then I will show you the code for the one I created at the beginning. Okay, now I'm going to show it to you. Here it is. Probably not even going to bother running it. So at the beginning, I didn't actually create a variable in this one because I didn't need to. So I just have my print statements. Then I have my non-println statement, so we can label what the user's saying. We check if the user's saying poorly, just putting sc.nextLine into this conditional statement because I'm lazy and didn't want to use a variable. Then it prints out, I was having so much fun until you said that. Why you gotta ruin my day like that, you jerk, if the user does say poorly. And if the user does not say poorly, we go system.out.println, I'm well too, what is your favorite pet? And then print the user. Then in the next conditional statement, we check if what the user said is iguanas. Then we print out agreed, they're the best, if the user did say iguanas. And then if the user did not say iguanas, we say, I never even heard of those, you're trash. And then at the end, we just say bye. And again, all of this here is just two of these structures nested inside of each other. Like the first layer, like the innermost layer of these, could represent the contents of this else statement, because right at the beginning we're checking this condition and then doing this if it's true, this if it's false. And then all of that is nested inside of this, where we check this condition, and if it's true we do this, and if it's false we do this. And then it joins up all at the end to do this. And for these two, the D they join up to do isn't actually anything. It doesn't print like... So that's it for talking about pets. Or something like that. So now go ahead and create a chatbot of your own. The possibilities are endless. Thanks for watching, guys. Remember to subscribe if you plan on watching future videos, and I will see you next time.